guys, welcome to another video lab of MrLopezClasses.com. This is our course of marine diesel engines, and we are going to do the calculation of the turbocharger. We are going to size the turbocharger appropriated for the diesel engine that I have in this moment naturally aspirated. And we are going to solve it a real example. We are going to calculate the turbocharger for a typical engine Caterpillar, the Caterpillar 3126B. This is an engine of a 6-cylinder. This is a famous engine used in agricultural, in transportation, in boats. In different applications is used the 3126B Caterpillar. It's a 6-cylinder, and that engine is coming in between 175 horsepower and 330 horsepower, 175 naturally aspirated, and 330 the maximum horsepower produced for that engine when the engine is turbocharged. In this particular case, we have the engine naturally aspirated, 175 horsepower, and we are going to calculate what is the turbo recommended for that engine. What is the idea? I am going to explain the procedure to calculate that turbo, but I want that you use this procedure, this recommendation, and try to do the calculation for the turbo in other type of engine. For example, I love it, the John Deere 5.8 liters. Okay, the John Deere 6-cylinder. That engine is a nice engine, and you can use that calculation. This is a great example, but there are a lot of examples of diesel engines naturally aspirated. For example, the Perkins 401A. The Perkins 401A is naturally aspirated, but you can calculate a turbo for that engine in order to increase the horsepower. What is the recommendation? Try to check the manual, the original manual with the original specifications for that engine, and try to investigate with the manufacturer in the service manual, operational manual, how much is the maximum horsepower that that engine can produce in order to avoid destroy the engine. Why? Because if you introduce too much boost pressure in the combustion chamber with a big turbocharger, you can destroy the head and you can produce catastrophic consequences. For that reason, the most important part is, okay, this engine in this moment is naturally aspirated. Let me investigate what is the maximum horsepower that this engine can produce when the engine is supercharged. This is the most important question. Let me check in the manual. Probably when you check in the manual, you found that that engine is not recommended be supercharged. It's possible. The majority of the engines can be converted into supercharged following the specification of the manufacturer. Okay, in this particular case, we have this engine, the Caterpillar 3126, is in this moment 175 horsepower, and we are going to calculate the turbo recommended in order to increase the horsepower from 175 to 330 horsepower. Yeah, and we are going to calculate the turbo. In this chart are the specification. We have the bore of the cylinder. We have the stroke, the distance that the piston move. We have the engine displacement. We have the compression ratio. We have some basic information, and we are going to do that information in order to calculate the turbo recommended. And also in the second page, we have the dimensions, because remember that at the end of this exercise we are going to calculate the turbo, and now because the engine is turbocharged, the engine produces higher torque. Because the engine produces higher torque, we are going to calculate the new motor mounts, because the new motor mount should be strong motor mounts. Okay? Alright, this is the exercise, and we are going to follow this procedure. This is the procedure. The first situation is copy the information, the basic information from the table of specification of this Caterpillar 3126B. Okay, according with the manual, this engine produced the maximum torque, the peak torque at 1440 RPMs, 1440 RPMs. In that point, the engine produced the peak torque or maximum torque. This is important. Right now I am going to explain why that information is critical. Other important information is the engine is 6-cylinder. The bore is 4.33 inches and the stroke is 5.0 inches. The stroke, that's distance, and the bore is the diameter of the cylinder. The engine is naturally aspirated. With naturally aspirated produce 175 horsepower. If the engine is supercharged, the maximum should be 330 horsepower. Okay? Alright? The first step is calculate the engine displacement. You remember in our previous episodes the formula to calculate the engine displacement. You remember engine displacement in cubic inches is equal to pi times the bore square divided by 4 times the stroke of the engine in inches and times the number of cylinders. In this particular case, we have all the information is pi times 4.33 square divided by 4, and all of them times the stroke 5.0 and times 6 because this is the number of cylinders. And this is 441.8 cubic inches. You can convert those cubic inches into liters, and this is 7.2 liters. Great, great. This is an engine of 7.2 liters and 441.8 cubic inches. Okay, that information in cubic inches, the engine displacement, will be used in the next step. To calculate the CFM, because this is the information that you need in order to order the new turbo for that engine. Normally, when you want to order a turbo for an engine, the expert, they ask to you, okay, how much CFM you wanted? This is the question number one. The second one, how much is the boost pressure that you wanted? And the other one is the dimension of the exhaust manifold, the actual exhaust manifold, because according with those dimensions, they calculate the size of the turbo. Okay, this is the information that we are going to calculate in order to supply that information to the manufacturers, Garrett or other manufacturer of turbo, and they design the turbo for us. Alright, the first one was the engine displacement. The engine displacement is 441.8. Okay, now with that information we are going to calculate the theoretical CFM. This is the amount of air that you can introduce in the combustion chamber. Okay, and the theoretical CFM is basically the engine RPMs. The engine RPMs at the peak. The engine's RPMs at the peak. The peak is 1440, no? 1440 RPMs. This is the peak. In that point, the engine produced the peak torque. Alright, this is the first information. Is the RPMs times the engine displacement in cubic inches. The engine displacement in cubic inches, and times the volumetric efficiency. The volumetric efficiency. You remember in the video I explained that normally those engines, the volumetric efficiency is in between 85% and 100%. The diesel engines are highly efficient, in between 85% and 100%. Okay, in this particular example, and in general, I recommend use 90% of volumetric efficiency. And divided by the constant 3456 when the engine is 4-stroke. You remember that formula, no? That formula is exactly this one. You remember, this is the RPM at the peak, the cubic inches, the engine displacement, the volumetric efficiency, and 3456 if the engine is 4-stroke. If the engine is 2-stroke, you use 1728. Okay? That's the formula to calculate the CFM. Don't forget. Important information. Alright. This is the CFM, and we are going to calculate right now. The CFM will be 30. Excuse me. The CFM will be 1440 because this is the peak of torque times the engine displacement is 441, and times the volumetric efficiency is 0.9 because it's approximated 90%, and we are going to divide it by 3456, and the CFM will be 165.75 CFM. Okay, this is the actual CFM, this is the theoretical, but how much CFM I wanted? Okay, the CFM wanted, normally I recommended, if the engine is used no more than 30% additional. If the engine is a new engine, you can add it 50%. In this particular case, it's an used engine. Okay, I am going to use the actual 165.75, and I am going to add it 25% because it's an used engine. Okay, I am going to multiply times 1.25, and in that case, this is 207.18 CFM. Those are the magic CFM that I wanted. This is one of the information that you need keep in your hand when you order the new turbocharger. This is the CFM that I want. In this moment, because the engine is naturally aspirated, the CFM are 165. And I wanted 207 CFM. I'm going to add it 25% additionally because it's a used engine with a lot of hours on the engine. Alright? No more than 30%. In this particular example, it's an example, I am going to add it 25%. Okay, this is the first information that I have. It's an important information. Don't forget, this is the CFM that I want, CFM. Okay? Now we are going to continue in order to calculate the pressure ratio. The pressure ratio. Okay? We are going to calculate the pressure ratio. The pressure ratio, to calculate that value, is simple. The pressure ratio is equal to the horsepower that I wanted at the end. I wanted 330 horsepower. And in this moment, with the engine naturally aspirated, I have 175. How much is that ratio? Is 1.88. What is the meaning of that? 1.88. This is the pressure ratio. I have 0.88. I have 0.88 over the atmospheric pressure. The atmospheric pressure. How much is the atmospheric pressure? At the sea level is 14.7 psi. 14.7. Okay. For that reason, the boost pressure the boost pressure will be equal to the atmospheric pressure, 14.7 at the sea level, times 0.88. The additional, and this is 12.93. 12.93. I am going to round it up to 13 psi. Okay, wow. This is the boost pressure. This is the boost pressure. This is the second important information. I have right now two information: the boost pressure, and I have also the CFM. Bingo! Practically my calculations are ready because I have the most important information, 13 psi. Remember that in diesel engines is recommended a boost pressure, extra pressure in between 10 psi and maximum 20 psi. 20 in case that the engine is new one. In this particular case, the engine is not new one, it's an used engine. Or 13 psi is conservative, is okay. It's in the low range, and you protect the engine. Remember that it's an old engine with all piston rings, a little plate on the bearings. If you introduce excessive boost pressure, you can destroy the engine. Okay, in this particular case, I am going to add 13 psi of boost pressure, and I wanted 207.18 CFM. Okay, wonderful. Yeah, I have practically all the information. What is the meaning of that? That with this extra pressure, with this 13 psi in boost pressure, I am going to pass from 175 horsepower into 330 horsepower. What is the meaning of that? I am going to add it. I am going to gain 155 horsepower. Wow! With this extra boost pressure, I am going to obtain 155 more horsepower. This is a lot. This is practically double, because in this moment I have 175, and I am going to add 155 more. Wow! And wonderful, wonderful. This is the situation. Okay, let me check what happened with the torque, because remember the torque. You remember the formula for the torque? The torque is equal the horsepower times 52 and divided by the RPM. Okay, remember, we are going to use the RPMs at the peak, because in that point is that you obtain the peak torque. Okay, we are going to talk the original. The original is the horsepower, 175 times 52 and divided by the RPMs is 1440. And how much is that? This is 638 foot-pounds. And now the torque, the new one, the new torque is the horsepower is 330 times 52. This is a constant to convert units, and divided by 1440. And how much is that? Is 1203 foot-pounds. Wow! Look at the torque. The torque is doubled. In my new engine, I have double torque. All right, be careful with that, because right now I have double torque. Probably I need bigger motor mounts. For that reason, my friends, you need calculate the motor mounts, and we are going to calculate the motor mounts. Okay, now we are going to calculate the motor mounts. In order to select the motor mounts, I need the thickness of the stringer. This is important. in this particular case, the stringer, the thickness is 5 inches. 5 inches. This is important in the moment that you need to select the motor mount from different manufacturers. Okay, and in order to select the motor mount, I need to calculate how much is the total vertical force that the motor mount support. And if you remember in our previous slides, normally the engine is inclined, and the front motor mount support 40% of the total load, and the rear motor mounts they support 60% of the total load. Okay, the front motor mounts 40%, and the back motor mounts 60% of the total load. This is only because the weight of the engine plus transmission. Engine plus transmission. Okay, we are going to check how much is the weight of the engine, included the oil. The weight of the engine is 1320 pounds. And how much is the weight of the transmission? The transmission is 330 pounds. How much is the total weight? The total weight is equal to 1650 pounds. This is the total weight of an engine plus transmission with oil, both of them. It's 1650 pounds, 1650 pounds. Okay, now we are going to calculate the vertical force, the total vertical force in order to select the motor mounts. The total vertical force vertical have two components. The vertical force because the weight plus the vertical force because of the torque. Yeah, the vertical force have two components. One portion because the weight of the engine plus transmission, and other portion because the torque produced for the engine. Okay, we are going to calculate in this particular case the component because the torque. The component because the torque is simple. We have the torque is equal. The torque is equal to 1203 foot-pounds, and according with the formula, the basic formula for the torque is equal the force times the radius. The radius in foot. Okay. How much is the distance, the separation in between the motor mounts? According with the table, the separation in between motor mounts is 32 inches. What is the meaning of that? The separation in between both of them is 32 inches. The radius is 18 inches. Okay, the radius will be 18 inches. Okay, the radius is 1.33 feet. Alright, you convert 1 feet equal 12 inches. 18 inches is 1.33 feet. Okay, in this particular case, the force is equal to 1203 foot-pounds divided by the radius in feet, 1.33 feet with feet. And this is 902.47 pounds. This is the vertical force because the torque. And now we are going to calculate the vertical force because the weight. Remember, the front motor mounts support 40% of the total weight, and the back motor mounts support 60% of the total weight. Okay, now the vertical force because the weight is divided in the front motor mounts. The front motor mounts is the front motor mounts is the total weight, 1650 pounds divided by 4, because I am going to calculate per each motor mount, and 40% is times 0.4, because it's 40%. And this is 165 pounds. And this is the front. And the rear motor mounts is the total weight, 1650 divided by 4 and times 0.6, because it's the 60%. And this is 247.5 pounds. Okay, I have the components of the vertical force because the weight, and I have the component of the vertical force because the torque. And right now it's simple because I need added both of them. The front motor mounts, the total is 165 plus 902.5, and this is 1067 pounds. And the back motor mounts, the rear motor mounts, the total is 247.5 plus 902.5, and this is equal to 1150 pounds. Okay, I have the total vertical force for front motor mounts and the total vertical force for the rear motor mounts. And I have the thickness of the stringer, and now it's easy because I have the vertical force and the thickness. Select the appropriate motor mount. I have the information. It's important that you keep in mind this. If this is the engine, this is the front view of the engine. This is those are the motor mounts, and those are the stringers. If the engine is rotating clockwise, the motor mounts of this side are working in compression, and the motor mounts of this side are working in tension. Which motor mount will be broken easily? The motor mount of this side or the motor mount of this side? This one, because the motor mounts are working in tension. For that reason, when you select the motor mounts, you need to take in consideration which one is in compression and which one is in tension. Some manufacturers, they have a different specification for the motor mounts in compression and the motor mounts in tension, depending on the manufacturer of the motor mount. There are a lot of companies dedicated to fabricate the motor mount. Right now you have the information, you have the total vertical force, you have the thickness of the stringer, and you have the information about which one is in compression, which one is in tension. This is important in the moment that you install the motor mount. If not, you can install the motor mounts in any position, but in some years, the motor mounts working in tensions are broken. The rubber on the motor mounts will be broken. This is the theory related with the calculation of motor mounts with the calculation of the turbo. Okay, now what is the next step? The next step is you have three important information. You have the CFM wanted. You remember? You remember that information? You have a 20718. 20718. This is the information. It's 207.18 CFM. You have the boost pressure. The boost pressure is 13 psi, You have the dimensions. You have the dimensions of the exhaust manifold. Basically, if you have the gasket of that exhaust manifold with that information, you supply that information about the dimensions, diameter of the exhaust manifold, copy of the gasket. You remember that gasket? Okay? You take a copy of the gasket, you have this information, this information, this information, and you have information about the motor mount. This is for motor mounts. With this information, you can select, you can order the turbocharger recommended for that engine. This is a complete design. This is a complete calculation. I want that you practice. Once again, you can practice with any other type of engine. If you have any other type of engine, naturally aspirated, you can calculate. You can size the turbo recommended for that engine in order to obtain the maximum horsepower recommended for the manufacturer. Be careful with that. Never try to pass the limit recommended for the manufacturer because you can destroy the engine. My recommendation is check in the manual of that engine if that engine can be converted in a turbocharged engine, or if that engine is originally coming in both versions, in naturally aspirated version and in turbocharged version. And try to do the calculation of the turbo. This is only to verify if you know, if you understand what is the meaning of the turbo. You understand in this process is simple. With this additional boost pressure, 13 psi, I convert the original engine 175 horsepower into a new engine of 330 horsepower, only with this additional boost pressure, and of course with more air in the combustion chamber. Now I have 207 CFM. Yeah, I passed the horsepower practically double from 175 to 330, only adding 13 psi. This is the meaning of the turbo. I introduce more air at high pressure in the combustion chamber, and I increase the horsepower and the torque dramatically, because I increase the horsepower 85% more, but I double the torque. You remember how much I increased the torque? You remember that calculation? The torque passed from 638 into 1203 foot-pounds. The torque was double right now. Okay, great. This is the procedure. I hope you enjoy this calculation. I hope you practice. Try to calculate other turbo for other engine. Try to calculate by yourself or with your instructor in your school. Thank you.